All right, welcome to 12.2. In this section, we're going to talk about the division of polynomials, and we're going to use the idea of long division, and then we're going to talk about this idea of synthetic division. All right, I'm going to start with something that we're probably familiar with, and that's why I call it kind of fifth grade math. We're going to talk about long division using just regular numbers, and use that as our guide in terms of long division for our polynomials. So let's say that we have something simple like 37 being divided by 3. Recall that 37 is known as our dividend, and we're going to call that P of x. Our 3 is known as our divisor, and we are going to call that d of x. Okay, so when we go and actually do our division, we're going to put our 37 here, and we've got our 3 here. Reminder that you were taught that you're supposed to figure out how many times 3 goes into 3, which would be once. 1 would multiply by 3, and you would get a 3 here. And then remember that you would subtract, and when you subtract 3 minus 3, it would cancel out. You would bring down the 7, and you would then ask yourself again, how many times does 3 go into 7? And you would say that it goes in twice. And you would take that 2 and you would multiply by that 3 out in front, and you would get a 6. You would subtract, and you would have 1 left over. All right, so this 12 that we have up here, reminder, it would be called your quotient, and we will call that Q of x. And then down here, your 1 is your remainder, and we will call that R of x. All right, so we can now say that 37 is equal to 3 times 12 plus 1. So what does that mean in terms of all the words that I've been using? Well, our dividend, P of x, is equal to our divisor, D of x, times our quotient, Q of x, and then plus our remainder, R of x. So 3 times 12 is 36, plus our remainder of 1 gives us our 37. Okay? All right, so that's what we're basically going to do, is we are going to figure out what our quotient is. We're just going to do it in terms of polynomials, and sometimes we'll have a remainder, but we don't always have to have a remainder. Sometimes it could go in evenly, and if that happens, we call that a factor. All right, so let's go ahead and take a look at our very first example here. We start with our 4x squared plus 5x minus 3 inside of our division symbol here. And we have our 2x plus 1 out in front. All right, the way that you get started is you start with the first term and the first term, and you decide how many times does 4x squared, or how many times does 2x go into 4x squared, and you would say that that's 2x. So this 2x is going to go above the second term. Okay, why the second term? Well, 1, 2, so I'm going to go in 1, 2. All right, now I take this 2x and I have to multiply it by those two terms out in front. Okay, and then the results are going to go underneath. So 2x times 2x becomes a 4x squared. A reminder that these two terms should be exactly the same, so they cancel out. And then the 2x times the 1 gives us a 2x. All right, big idea that we have to remember is that we are subtracting. Okay, so when I do 4x minus 4x, or 4x squared minus 4x squared, they cancel. 5x minus a 2x gives me a 3x. I bring the next term down and I have minus 3. You always want to have two terms when you have two terms. If I got two terms here, I want to have two terms here. Like I did earlier, I always take the first term, the 3x, and figure out how many times 2x can go into it. Well, 3x divided by 2x, the x's cancel, and I'm left with 3 halves. So I'm going to put a 3 halves up here. Now I take this 3 halves, and I have to multiply it by the two terms in front and put my result down here. So my 3/2 times my 2x gives me a 3x. And then my 3/2 times 1 gives me a 3/2. Then I am going to subtract. So 3x minus 3x cancels. And then a -3 minus a 3/2 gives me a -9/2. Okay, and if you would prefer, you could write that as -4.5. But that's really up to you. Okay? All right, so in terms of writing it like we have above with our, quotient and our divisor and our dividend, we could say that 4x squared plus 5x minus 3 is equal to a 2x plus 1 times a 2x plus 3/2 and then minus a 9/2. And that was our goal, was to be able to come up with that. All right, let's try this again. This time, you have a situation in which the numerator has some missing exponents. Notice it goes from an x to the 4th to an x cubed, all the way down to a constant of 2. All right, so something to help you out when you go to set this up. A suggestion, and it's really up to you on whether or not you want to do this, is I usually write it out as 3x to the 4th minus 2x cubed plus 0x squared plus 0x and then plus 2. I always try and write it in a descending order, okay, 4, 3, 2, 1 in terms of my exponents. And this is also an idea that we're going to have to carry over when we get to synthetic division anyway, so I just like to be consistent. So I've got my x squared minus 1 out in front. And like above, we said you always try and figure out how many times x squared can go into the first term over here. So if I've got 3x to the 4th divided by an x squared, I'm left with a 3x squared. And that I'm going to put above the second term. So I've got a 3x squared here. All right, remember I'm going to multiply this through by these two terms. Okay, and that's going to give me a 3x to the 4th. And then 3x squared times a -1. I'm going to write all the way over here at a -3x squared. The reason I'm going to do that is I want to line up my like terms. I have to remind myself that I am subtracting. Okay, so when I go to do this, 3x to the 4th minus 3x to the 4th cancels. I've got my -2x cubed subtracting nothing, so therefore this stays. And then I've got an x squared minus a -3x squared, which becomes a positive 3x squared. Like I said earlier, since I have two terms out in front here, I always want to make sure I have two terms. So I don't have to bring anything down just yet. I have to figure out how many times x squared can go into my first term here. So -2x cubed divided by an x squared. Okay, if I simplify that, it looks like I get a -2x. And that -2x I'm going to write up here. And then reminder that I want to multiply that through. So -2x times x squared gives me a -2x cubed. A -2x times a -1 gives me a positive 2x, which I'm going to write all the way over here, where it has a like term. Okay, I am going to subtract, and a -2x cubed minus a -2x cubed cancel. And then I can bring down my 3x squared. And I have to recall that I am doing 0x minus a 2x, which is a -2x. I'm going to do my first term concept again. So 3x squared divided by x squared. So 3x squared divided by x squared. It looks like that's a 3. So I have a plus 3 here. 3 times my x squared gives me 3x squared. 3 times my -1 gives me a 3. I'm going to put it all the way over here next to my like term. I am going to subtract. And when I do that, my x squareds cancel. I've got a negative 2x that I can bring down. And then I'm subtracting a negative 3, which means I'm adding a 3. And this, then, is technically my remainder, because I went from an x squared down to an x down to a constant, and so I don't really have anything else I can go beyond, so this is my remainder. So I can write it like I did up here with my quotient and everything, that 3x to the 4th minus 2x cubed plus 2 is equal to an x squared minus 1 times a 3x squared minus 2x plus 3, and then plus my remainder of negative 2x plus 3. Alright, so just some good practice with long division, and we will definitely practice more with this tomorrow in class. Alright, on to page 2. Alright, synthetic division. You're going to like this. It's probably going to go a lot faster too. Alright, synthetic division. Big idea here is that you have to have a leading coefficient of 1 in front of our x's. And most of our examples have that, so that's going to keep it very simple. Alright, with our dividing, all you're really going to focus on is your coefficients. But the first thing that we have to do is we have to take this x minus 2 and we have to set equal to 0 and solve. So x is equal to 2. So we're going to put our little 2 here in the box, and then we're going to take our coefficients and we're just going to write them straight across. So 3, 2, and negative 1. If you had any terms that were missing, you would fill in with a 0, and you're going to see that on the next example. Alright, you always bring the first number down, and then remember, you take the number that is in the box and you're going to multiply the number that is underneath the line. So 2 times 3 gives us a 6, and we put the answer here. Okay, and then you're always adding. So 2 plus 6 gives us 8. We take the number in the box, we multiply by the number underneath the line. 2 times 8 is 16, and then we add. So negative 1 plus 16 gives us a 15. The very last number that you come across here is known as your remainder. Okay, so if we do like we did in all of our other examples, we could say that 3x squared plus 2x minus 1 is equal to x minus 2. And then here's the thing that we need to understand, is that since we took an x squared and divided by an x, this first term here is an x, and then we descend from there. So if this is an x to the first, then now we have our constant, and then remember that this is our remainder. So this part here becomes 3x plus 8, and then we have plus 15, our remainder. Alright, on to example 4. So in this one, we have a x cubed minus an 8x squared and then minus 1. So, and then divided by an x plus 3. So the first thing you should understand is that we're going to have a negative 3 in the box after setting our denominator equal to 0. As I go across, I have a coefficient of 1 for the x cubed, a negative 8 for the x squared, a 0 for my linear term for the x, and then a negative 1. So just like we did with the long division, I'm going to fill in with a 0. Bring the first number down because you're always adding, and you're adding 1 to nothing, and you get 1. Negative 3 times 1 gives me negative 3. I add, I get negative 11. I multiply negative 3 times negative 11, I get 33. 0 plus 33 is 33. Negative 3 times 33 is a negative 99. And negative 99 plus my negative 1 gives me negative 100. Alright, so I started with an x cubed and I divided by an x, which means that I have x squared left. then an x, and then I have my constant. And then remember that this is my remainder. Okay, so here is my polynomial with my remainder. So I've got x to the third minus 8x squared minus 1 is equal to a x plus 3 times an x squared minus 11x plus 33, and then minus 100 for my remainder. All right, because the video is going a little bit long, I'm going to skip example number 5. And what we can do is we can come back to it in class and use that as an opening example tomorrow. So let's just go ahead on to page 3. All right, in this last example here, it says for us to find the value of k so that k plus 2 is a factor. Now, I said this at the beginning of the video, that if it is a factor, the big idea that you need to understand is factor means that you have a remainder of 0. Okay, that's important. You need to understand that idea in order to solve this. So I'm going to use synthetic division here. And since I am dividing by x plus 2, I'm going to put a negative 2 in the box here for my synthetic. Now going across here, it looks like I have a 1x cubed, I have a 0x squared, I have a kx, and then I have a negative 1. Now, why is the remainder equal to 0 so important? Well, then that means that at the very end here, I have to have 0. So let's just do, you know, a little math and work backwards, okay? So if I have to have a 0 here, that means I have to have a positive 1 here for them to cancel out and be 0, okay? So think about that. All right, next, I'm going to start over here on the left side. And remember that I'm going to bring the 1 down. I'm going to do the negative 2 times the 1, and I'm going to get negative 2. 0 plus negative 2 is equal to a negative 2. Negative 2 times negative 2 is a 4. And now I've got a k plus 4 here. All right, so think about this then. I am going to take this number and I am going to multiply that, and it has to equal this. So negative 2 times k plus 4 has to equal a 1. Negative 2k minus 8 equals 1. Negative 2k equals 9, and k is equal to negative 9 halves. So what we did here was we used a little bit of, synthetic division in order to solve. Now, is the method that I used here the only way that it could have been done? No, we could have also just done it in another way. We could have done our negative 2, our 1, a 0, a k, a negative 1. We could have brought our 1 down, negative 2, 4, k plus 4, and then we could have done negative 2 times k plus 4 is negative 2 minus 8, and then negative 2k minus 9 is equal to 0 and solve, but you pretty much get the exact same thing.